is everyone? This is Emily from Team 17. Are all the evaluators here?
Sure.
This guy answered, wait, what's that? A neglectful faculty member at a university? I've never heard of such a thing.
Nonsense, right?
Oh, wow, that was
Yeah,
weird.
he was busy trying to get his PhD out the way, and I think he just got the bad news of tenureship and all that stuff, and he like totally checked out.
All right, this, after I finish speaking, this will be where I,
Yep.
yeah.
I love the guy.
Okay, wonderful. Welcome to Team 17's InWorld. Before we get started, I just want to thank all of you for this wonderful opportunity. I think I can speak for the rest of Team 17 when I say that this has been a great learning experience for all of us. And we're really excited to show you what's been worked on over these past couple months. So if you want to follow me up the stairs, I can introduce you to the rest of the group. Hello everybody, this is Annika. Jocelyn isn't here right now because her computer just died, but she'll be back in a minute. This opportunity presented to us by NASA allowed us the chance to create a model that would help improve our knowledge of critical thinking, identifying problems and generating solutions, and to create a model that would benefit those in need. Using technology from the James Webb Space Telescope, we were able to create a spin-off using its multi-layered sunshield. By adapting this sunshield to accommodate the needs that work in favor of our model, we were able to design a feasible spin-off that would conserve heat inside or be reversed, expelling heat to keep the interior cool. The goal we wanted our spin-off to accomplish is to generate an affordable, convenient way to provide a greenhouse type of technology to those who need it most, which would be people that rely on gardening and agriculture in their everyday lives. By doing this and having a feasible design that would work, it would be ideal for the spin-off to be made out of something lightweight and durable, which is why the JWST sunshield would be incorporated into our design. I'm going to pass it off to Samantha now. Yep.
Hello everyone, and thank you for coming to our Team 17 OPSPARC InWorld presentation. Now I'm going to hand it off to Annika. The James Webb Space Telescope, sometimes called JWST or Webb, is an orbiting infrared observatory. It was built to extend the Hubble telescope's ability to discover. The JWST uses longer wavelength coverage and greatly improved sensitivity. The longer wavelengths will enable JWST to look much closer at the unobserved formations of the first galaxies, as well as to look inside dust clouds where stars and planetary systems are forming today. The JWST has sunshield membrane coatings, which is what we used in our spin-off technology. The telescope has to be kept cool, and the sunshields keep it in a stable condition. The sunshields reflect the sunlight away from the telescope and simultaneously shade it and keep it cool. Of course, we didn't have a NASA-grade sunshield, so we used a sunshield that you put in the windshield of your car. It serves the same purpose, reflects sunlight away, and keeps the interior of the car cool. Okay, now if you please follow me, we'll proceed along the white arrow path into the design process and team info room. Along the walls, you will see our problem statement diagrams of our designs, along with descriptions of designs, criteria and constraints, and our 3D model of our final design of a JWST sunshield spin-off technology.
Oh. Hey. Sorry.
Thank you, Samantha. With a sunshield similar to the one on the James Webb Space Telescope, our spin-off would allow us to manipulate the inner temperature. Since the sunshield is 5 layers, we can change where heat is released, meaning we can make the inside warmer or cooler. Sun shield works by absorbing the heat through different layers, but what this really means is that it releases the heat between the 4 gaps within the sun shield, causing the final layer to have little heat left to get inside. The current model that we physically made would not have as many benefits as if it were made with this 5-layer sun shield on the telescope. Our spin-off is able to keep the plant inside in a warm temperature, but it currently isn't optimized for keeping it cool. Something that we would look to upgrade in the model, besides the sun shield, is how much room is on the interior. The model we made was very small scale, and if we were to actually make one that we would want to use for convenience, we would definitely make it much larger and able to house more plants. Okay, now if you please follow me along the white arrow path to the content application and merit of design and marketing plan room. Along the way, you will see posted on the wall of other parts of the James Webb Telescope. As you enter the content application and merit of design and marketing plan room, to your left and following around the room is science behind our JWST Sun Shield spin-off technology. Making a design for a model proved difficult as we needed it to be constructed of affordable material we had access to and still be able to function properly. We needed to design something that would isolate the plant inside to be able to manipulate the interior temperature. We had many different ideas on how to increase the heat that the model would conserve, but we chose one that we did because it completely enclosed the plant, making sure no heat was escaped. If we use the 5-layer sun shield on the JWST telescope, adjusting the layered gaps so that they are stacked on top of each other on the outside, the heat would be pushed through the gaps and out the side, so no heat would get to the interior of the model where the plant would be. Doing this would allow us to control how cool we would want the temperature inside. If we wanted to keep the inside of the model warm, we would adjust the layers so that the gap is on the inside, pushing the heat into the model. Another way of conserving the heat would be to make a full circle with the sun shield, aligning the gaps with each other so the heat would not get in or out. Along the wall to your right, following after the science behind our JWST Sun Shield spin-off technology is our marketing plan. For our marketing plan, we will sell our spin-off technology to third-world countries who greatly rely on agriculture at an affordable price. With this plan, there lies a problem of connecting with these countries. To solve this issue, we can form partnerships with non-profit organizations like USAID, the United States Agency for International Development, and use this to connect with countries who would be interested in this product. But there still lies the problem of figuring out the price. While the JWST costs a total of $10 billion, the Sun Shield costs just a fraction of that. Since our spin-off technology product won't be the size of the actual JWST Sun Shield, which is 21.197 meters by 14.162 meters, it will cost a lot less. But since we still have to factor in the price of the other materials going into our JWST Sun Shield spin-off technology product, in order to make this product affordable for our customers, we will lower the price so it's inexpensive. With this money received from these sales, we can pay off the difference and continue manufacturing and selling our product. With this system, we can sustain our product while helping those in need all over the world. Okay, now if you please follow me, we'll go back along the white arrow path into the design process and team info room, where along the wall you can view information about our team and the responses to the final reflection questions. Okay, the skills we gained while working on our product are time management, 3D modeling, collaboration skills, research skills, and presentation skills. We had to make sure we met all the deadlines on time and meet all the criteria so that our project was high quality. InWorld allowed us to improve or even learn a new skill, 3D modeling. We also had to figure out how to work together in a way that prevented arguments and allowed for sharing of ideas without judgment.
Before we even created our spin-off technology, we had to do research on the James Webb Space Telescope. By researching, we figured out how sunshields work and especially how the James Webb Space Telescope's sunshield works. Finally, we had to put all of our findings together in a presentation that explained what we did in an understandable way. These skills will help us throughout our lives and are preparing us for jobs we'll have in the future.
Okay, now if you can please follow me back along the white arrow path and up the stairs to the model of the JWST outside the Earth.
And we have to go. Okay.
We would like to thank you all for coming to our Team 17 OPSPARC InWorld presentation. And now if you'll follow me along the white arrow path into the lounge where we can provide answers to your questions and receive comments for the remainder of the time.
Okay. Like the alien that looks like a praying mantis without legs.
Alright, do you guys have any questions or comments?
So how large do they anticipate that one of these could be? How?
Hello, this is John representing the NIA admin team and the New Jersey Institute of Technology. In one of the pieces of data you mentioned that the temperature inside in the design that you have would be able to go up to 120 degrees, which sounds a bit too dangerous for certain plants. But I was wondering if you guys had any other intentions with the design. Has there been any thoughts about putting this spin-off into use in other applications, such as food service or other products that may need to be stored in a large amount of time and heat? That's all. Thanks.
Thank you for the question. And to that, I would say definitely we could apply this technology to other industries that would need it, like food services, like you said. And we could use it to keep food warm, as you mentioned. And when you said that it 120 degrees, I think we would be able to adjust the heat lamp. We could get a different one and implement that into our design and be able to adjust the temperature, like the maximum temperature, so it doesn't fry inside. But other than that, yeah, we could definitely use our technology for other things other than plants and gardening.
Alright, it looks like there's a question from Amber written in the chat, which is how large do you expect one unit to be?
So we expect it to be about the size of an average table, which would be about a yard by a yard, if that really answers your question.
Our original model that we made in class was actually pretty small, but I feel like if we had the right tools, I guess, like a NASA grade sunshield, I guess, we could make it to the size that Samantha mentioned. Another question from Sharon is, how are you controlling the temperature in the plant growth area?
That is a good question. Currently with our model, we aren't able to control the temperature because of our budget, but if we had the funds, we would definitely upgrade the model so that we could have adjusters and like a lamp that would shut off on a time limit and make sure that when it gets to a certain temperature, it would shut off immediately, and so it contains the temperature range.
Okay, another question from Kelly. Did you mention whether this was intended for a specific environment, for example, the desert, cold, or all weather?
We didn't intend this for a specific environment or temperature because we wanted to make this model so it could be in any temperature and be adaptable to different environments and different people's needs, so it could benefit most people.
17, thank you so much for a wonderful presentation, and we certainly have enjoyed all of the twists and turns of your team world. You've done an amazing job in building. I also would like you just to realize that while I'm here as an avatar, I am representing 1, 2, 3, 4. I'm going to ask them all to introduce themselves to you. So, Barb is here. Barb Madsen from Astrophysics.
Party mode.
Yeah.
Thank you again, Team 17. We may stay in this area to explore just a little bit on our own, but you do not need to stay with us, and we'll be able to find our way back to ground zero. Many thanks to your team leader, Emily. Emily, we know you've had some extra challenges in doing this all on your own, but we certainly are very impressed by the work that you've been able to do with your students. And thanks to all of the members of Team 17.
All right, thank you all for coming, and thank you for listening. Yeah, we're great.
Thanks for giving us this opportunity to present our idea to you, and we hope you
Have a great day.
Yeah.
Ooh. All right, bye.
Bye.
All right, thanks again, all. We really appreciate this opportunity, and yeah, we look forward to hearing more in the future, and hope you all have a great rest of your day.
Did they have or did I miss the 3D model of their spinoff?
I didn't see it.
They could not upload it, and
They said to click on it though, click
Yes.
on a box or
Yeah,
something to
so-
see it.
but here's the thing, I'm pretty sure that it wasn't able to link. So I can try. Oh,
Yeah, go back and find it. But,
oh,
so question.
Mm-hmm.
They,
I don't even know where it was.
they've got their little heat shield, their little heat lamp and all that, but
Mhm.
do they tell us how that heat lamp's getting powered? Do you have to plug it in? Is it, I mean, they're not using just solar.
Yeah, I was kind of lost on fully what the concept was beyond
Oh,
just
okay.
thinking it was kind of a greenhouse type thing,
Yeah.
but how it was actually going to work.
Let's see.
And Sharon loves to see all of the stuff in here, the Greek architecture and the
Yeah,
snow.
yeah.
I don't.
I find it terribly
Okay. I do
distracting.
too, and I think it takes away from, I mean,
It does.
yes, it shows that they learned how to build
Mm-hmm.
and to create InWorld, but they spend more time on that than they do
Then
on
I
the
did
content
the
thing.
project.
Yeah.
Mhm.
Um,
And
Yeah, and I will tell you, this group did not have anything in there for quite a long time. And also, one of their mentors did drop out.
Yeah.
But this is so much better than it was.
I think they all.
Yeah.
that.
No,
mean,
I'm
that's kinda
telling you,
typical.
there was nothing except columns.
Yeah, and that's kind of typical for so many of the kids, they wait
Yeah.
till that very last minute.
Let's
So you do
see.
your best work.
Yeah, that's right.
Trying to think where it was.
Yeah.
Oh, God, there's so.
Yeah, because it's not, I mean, it's really not, it's clearly marked on the floor, but it's not clearly marked where the different rooms are.
Yeah.
There's, I think it's right there. Remember where it says JWST and there's a picture off to the side here?
Right or left?
To the right as you're looking at it, right, see that picture of JWST? I think it was in that area. There's their model of the, see it up above there?
Oh yeah, there it
Yes,
is.
there's GWST.
There's the
but
JWST.
Okay.
They have a model of
Now,
their.
do they have a
Read
model?
that blue box.
Yeah.
Here to open the 3D model of the James
Okay.
In a new browser. See,
God.
there's not the ability to do that.
Well,
And
but I mean,
But
yeah, I'm
they've
okay
got
with
their
that.
model of the 3D, so there's
Yeah.
that one.
Mhm.
Okay, so
Okay,
now,
well, what we don't have is a model that I'm
do they
seeing
do
of their
a model of
solution.
theirs? I saw drawings of
Yeah.
Drawing.
yeah, no, there was. Click here to open our 3D blah 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 in a new
The sun
browser.
shield.
Just the sun
Okay.
shield.
Yeah,
Okay, so.
but we don't have that capability.
So whisper to Sharon and ask her if there's a model of their
Spin-off.
spin-off.
It's only 185 Fahrenheit on the outside. That's awesome.
this thing's out at Earth's sun altitude, right?
Right.
Right.
Which is going to be behind Earth, so it's going to be a little further, but like a very little bit further up than you.
Oh, Margaret asked too.
Except on
There's a picture of our model in our blog, which is over here.
Yeah, but we're not supposed to actually take their logs into consideration because that was
Right,
evaluated previously.
right. So,
This is negative.
And I didn't even see their glog posted anywhere.
I did.
Oh, was it in this room?
I don't remember where it was.
I
but it
don't
was-
either.
It was there.
Yeah. Okay.
Okay.
So it's kind of like a parabolic reflector on top, or is that just like the bulb?
No, I think that's what they were talking about with the,
Okay.
Yeah, that helps.
Is there anything else that you would like me to attempt to navigate to?
I think that covered everything else.
Okay.
Are we supposed to reserve our own personal feelings with regards to the intricacies of their world? And
Yeah, that's-
actually credit them for it? Because
So-
it is work, but I know it's
It
not.
is, and so you might get, so like, that's one of the reasons why there's the 8.
There's the
points
Yeah.
down
freebie
there
or-
that you could-
Yeah, the
Yeah.
judge's choice points.
Yeah.
Okay.
Yep, you're fine, it didn't fall. Yeah, because you could give up to 8 judge's choice points.
But I'm asking, I guess, more for like this competition. Is that a favorable thing?
It can, I would say this, it is if you have two teams that their science and their concepts are equally
Good.
well, just, well-rounded and figured out, then the team that did more building would get more points,
Fair.
okay?
Fair. I agree with that.
So-
Okay.
Yeah.
So they gave advice, right?
They
Talked
did.
about their skills.
Mhm.
So,
And they had it posted on the wall,
yeah,
too.
they did. Okay.